Okay, the last thing we have in this unit is talking about entropy and what it is. So it has to do with the second law. We've talked about it a little already. But the way the second law defines entropy is your change in entropy is going to be equal to the heat of the system, or I guess it's the change of heat in the system, over the temperature in Kelvin. If you have a problem where it's changing temperature, for now, just take the average when you do calculations. But for real processes, always your entropy change has to be positive. Unless, so it's how you define the system. For an individual component, you can find that its entropy goes down. But if you define your system wide enough, it'll always be a positive number. So let's do an example problem with it. Let's say we have 10 kilograms of water at 25 degrees Celsius, and we're going to mix it with 1 kilogram of water at 75 degrees Celsius. I want to know what is the change in entropy of the system. I want you guys to attempt it. I'll give you a hint. You're going to need to use MCAT on this one. Go ahead and attempt it, and when we come back, we'll go over the answers together. Okay, let's go over it. So we know that when we add hot thing to cold thing, they're both going to reach the same temperature at the end, meaning that the heat one went up by was the heat the other one went down by, because those are the only sources for heat transfer. So I just set up my Q's equal to each other. This is my hot water. This is my cold water. Q equals MCAT. One's just negative. Since they're both water, I can cancel out the specific heat. And when I do that, I solve for my final temperature, and I get 29.5. So now I just do it for the lower temperature one. I plug in all my numbers, and I get a heat of approximately 190,463. Then what I'm going to do is come over here to my equation for entropy. Entropy is, remember, just Q over T. But in this case, I've got two different things that I'm solving for. I want to know the system as a whole. This is going to be for the cold water that's heating up. This is going to be for the hot water that's cooling down. Since we know the amount it changed, the cold water heated up, that'll be a positive number. The hot water cooled down, so that'll be a negative number. Now what I do is I just find the average temperatures for them. So here was for the low one. I did 29.5 plus 25. There's my average. Same thing with 75, 52.3. So what I do now is just put the temperatures in Kelvin. Remember, our units are temperature in Kelvin. And I go ahead and plug it in. And what you find is the one that was at a lower temperature ends up gaining more entropy than this one loses by cooling off. So what we find is that we have a positive entropy change, which is what we would expect for all real processes. And with that, we are done with the thermodynamics unit.